Good morning, everyone. Thank you so much for joining our session. We are again back in 2023 with new excitement, new energy to focus on continuous learning. That will be our motto for 2023. We'll ensure that we get our best for new sessions, new series, whether it's recap of reinvent or new technology. So that's what we are going to focus. And with that, we are back for the first weekend of our 2023 with a new session, and we'll have an interesting speaker. She is very renowned for this particular talk, and the technology is very common, which we always everyone prefer to do that, and we use day in day out. So today's session we will be learning around running microservices in Amazon EKS, which is Elastic Kubernetes Service, with App Mesh. And I have the interesting speaker to cover this session. But before we go ahead with the session, just want to announce a couple of things. Please ensure if you have any questions for the sessions, please put it in the chat. We will take all those questions at the end. And if you're watching this session on demand mode, if you're not able to join us today, unfortunately, and you're watching on demand mode, don't worry, put the questions on AWS User Group Slack channel. I'll share the URL in the comment, or you can put it on the YouTube comment form. I'll ensure Mahima and as well as I will ensure that I and as well as the team will ensure that all the questions are be answered at the end of the sessions. So that's from us. Let me get the speaker introduced. So today to cover the session, we will have Mahima Saran. She is from AWS. She is a senior technical account manager, Amazon Web Service India. And she has done, she's not a new face for us. She's doing the second talk for AWS UserGroup Mumbai. Last time in 2022, she was a speaker for our in-person session, which we conducted in June. And we have again her to help us to understand how the EKS and App Mesh works. So let me bring Mahima on the stage. Hey Mahima, good morning. How are you doing today?
Hi, Sanchit. Good morning, and thank you so much for the wonderful introduction. Hi, everyone. Hope you're awake. You had a nice breakfast today, and you are ready to listen to some of the App Mesh, microservices, and EKS. And we'll have a refreshing start to this morning today. And Sanchit, I hope by the end of this, our audience are enthralled and they're able to learn something out of it. And by the end of the session, they go back and they are very enthusiastic to know more about these technologies. So, guys,
Exactly. Yeah.
yeah, all right. So, guys, without wasting any time, I'll begin. I'm quickly sharing my screen and hope it is visible to everyone. So, first, a quick introduction about myself. So, I've been working with Amazon for almost 3 years now, and believe me, it has been a very overwhelming journey for me. I've done the kind of learning which I have not been able to do in my entire career. So, these 3 years were almost like almost 10 years of my experience, is what I can say. So overall, I have a industry experience of 17 years, where I was fortunate enough to work on various open source technologies. Initially, I was part of open source stack where I was trying out, and we used to do an R&D on various open source technologies, and that is where I was able to work on DevOps, microservices, and containers, and I had a very good specialization on microservice plus containers. And this is my LinkedIn handle, so if you want to connect with me, please send me your request and we can connect. And even after the session, if you want to connect with me, if you have any questions, please feel free to connect with me. All right, so this is the topic that we are going to discuss today. How running microservices, how we can run microservices in Amazon EKS along with AWS App Mesh. All right. So, guys, this is a this is what we are going to do today. We are going to answer some of the whys. Okay, why a service mesh? What is the need for a service mesh in today's industry? Why app mesh? I mean, what is the need for an app mesh, and what exactly is app mesh, and how it can help you solve your problems? And then we are also going to answer some of the hows. So what are the AWS App Mesh constructs? How do they help in solving all the issues that we will talk about? And then how App Mesh can be integrated with EKS, and how we can very quickly create our sidecar proxies and start injecting it into our EKS clusters. And then I will give you a short demo on how this could be done. And this demo is prepared from EKS workshop itself. So if you are interested in replicating it or trying out in your local machines, then this would be a very good fit. Okay, so this is the agenda that we are going to discuss. We'll first discuss about what are the key challenges that we face with microservices environment. Then why service mesh? What is exactly the need for a service mesh in today's world? Then what is App Mesh? Why do we need it? How we can use App Mesh with EKS clusters? Then we'll see demo application which is called as product catalog application, and we will try and meshify it using EKS and App Mesh. Okay, and then I'll give you a short demo of the application which is already running in my environment. Okay, let's begin. So, I'm not going to go too much in detail about what is microservices and why microservices, because we are just assuming that the audience here already has a good understanding of microservices, has a good understanding of what is EKS and how EKS works. So we are skipping the details of microservices plus EKS, but our main focus today is going to be what is AppMesh and how we can use AppMesh to solve our problems. So, as you all know, when we talk about microservices, which is a kind of an architecture, it basically comprises of two things, right? Whenever we talk about microservices, it has one which is a business logic. Now, business logic is where all your application code, your business functionality goes in, right? And which is actually used for integration with other services and how the services are going to work. Then the other portion of any microservice or the other component is a network functionality. Now, what do we mean by network functionalities? We usually break a monolithic application. When we convert a monolithic into a microservices architecture, we break a monolith into multiple microservices, right? And these services often need to communicate with 10 other services in order to resolve a query. So whenever a request comes into a microservice, it has to communicate with many number of microservices internally in order to get the response. Now, because we have now a network of so many services running within our system, the complexity of the networking is also increased, right? Earlier, if you are talking about a monolith application, everything is binded together in the form of modules, which is more or less like a inter-process calls which used to happen. But now when we are talking about microservices, it is no more a module to module call. It is a network call which happens between service A to service B and service B to service C, right? So that is where a lot of complexities start coming into the picture, which were no more there into the monolithic area, which are like resiliency, circuit breaker. What if a service is not healthy? How the request would be fulfilled when service A is not working as per the expectation or its health is down? How would you enable the service discovery, right? To understand what is the location of each service, on which node it is working, what is the IP address of it, in which pod it is exactly running. So how do we know the location of each of these services? So which comes under service discovery again. Then we have logging, monitoring, distributed tracing in order to have a granular control over the services, to be able to watch them, how their performance is, to be able to know when a request fails, what is the point at which your request has failed, right? So many complexities started coming into the picture which no more exist, which did not exist even during the monolithic area. So these are the key challenges which has started coming with the microservices. First is service to service communication. So when you are talking about 5 to 10 services and you are running in a very small cluster, it's very easy to do the service to service communication. You exactly know the points which we are calling each other. You have certain logic which is implemented. But imagine you are running 50 to 100 microservices, right? And imagine the complexity of managing the service to service communication between each of these services, which becomes very, very complex over a period of time. Then performance issues. You will see that many of your services would not be performing as per the expectation. The responses would be delayed. There would be certain services which are going to fail at any point of time, which is very evident. We expect in the IT world that everything is going to fail someday, right? So we cannot assume that our services will always be in a running mode and will be healthy. So we have to also manage that when a service dies, it should be in auto recovery mode, so that a new service is created in its place to handle the traffic. But while it is down, there should be another service in a high availability mode which should be able to manage that traffic. Same way, there are operational challenges also, right? You need a more fine granular monitoring of each of these services. You need to trace each and every request time and how the requests are, you know, going from one service to the other service. Another challenge is when we talk about microservices, we often say that one of the best qualities of a microservices, you can have polyglot languages, right? You have certain services, let's say, developed in Java, some of the services developed in Node.js, some of the services developed in .NET, for example. Now, while this is one of the qualities of a microservice, it also becomes one of the challenges. How it becomes a challenge is, now let's say you implement certain logic as a business logic. So when you're creating a microservice, you will implement the business logic. On top of that, you are going to implement all the networking logic of how the service to service communication is happening, how the fault tolerance is happening, how the performance, service discovery is happening. But imagine you have to write that networking logic into each of these different languages. So then you will have to write a logic into Node.js, you will have to write a logic in Python, into your Java code, and then it becomes so much of a complexity that over and over you are duplicating a code across hundreds of microservices. So if there is any change that you are doing, if there is any upgrade that you are doing, it becomes too much of a nightmare when you are changing the versions, when you are going from version 1 to version 2, and you always have to take care that your libraries and the services all are intact and they are functioning as per the upgrade process. You have to do a lot of testing, right? So again, it is becoming a whole lot of challenge when polyglot also comes into the picture. Then the security of these services, so we never expose the endpoints of any microservice directly to the outside world, right? We always create proxies, and the communication between the services or outside of the service into the network always happens via proxies. So it becomes again a different nightmare to maintain so many proxies for each of these services. So these are some of the challenges which we often face when we are dealing with the microservices. So let's imagine a use case of Amazon Pay. So whenever you talk about Amazon Pay, all of you must have used Amazon Pay while doing your purchases from Amazon.com. Because it's a payment service, it has to be highly secure in nature, right? No one should be able to access your payment system. The payment processing should be smooth enough. It should not fail in between, right? It should not happen that the money has been deducted from your account, but your payment has failed. It becomes again a very big thing for the users, and they have to redo the entire payment, and then we have to refund that amount into their banks. The notification, once the payment is completed, you need a notification that the payment was successful or the payment was unsuccessful, right? So now while we are doing this, you also have to consider about security, we have to consider about the connectivity, we have to consider about the observability. By observability means we should be able to observe each transaction, how it is going through, whether it has failed in between, whether it is giving the right result, correct? And at the same time, control, you should have a control over the entire service and the entire transaction which is happening here. So what we need a consistent communication management system. That means we don't have to worry about all of these challenges which we talked about. The communication should be very smooth. We don't have to do a redundancy and implement the logic for each and every service in different languages. We need complete visibility, right? We should have a visibility and fine grained visibility across each transaction which is happening between all these services. Failure isolation and protection, what do we mean by that is, if any of your services are failing, the other services should be notified, and the failed service should be isolated, it should be recovered, and other services should be able to take care of the traffic which is coming towards this particular service. You should have high availability, you should have failure protection, circuit breaker kind of logic implemented. Then fine grained deployment control, you should be able to deploy n number of times your services throughout the day. You should have many of your things automated in a way so that you don't have to worry about any new deployments which are happening or any new versioning which is happening in your services. So how do we implement these things that we need? So the solution that we have come up with, service mesh. So what is service mesh? It Service mesh is nothing but a separate infrastructure layer which will offload all the inter-service communication logic to a separate layer, right? So let's take a deeper look into it. Now, as you can see from this picture which you are seeing here, there's a guy which is riding a bike and there is a sidecar attached to it. So that is what is a service mesh. So this guy is nothing but your microservice which is running individually, standalone service. And service mesh is nothing but a attachment which attaches to the microservice, and it is responsible for managing all the service to service communication. So let's take a deeper look into this. So what exactly is a service mesh? So service mesh is basically a dedicated infrastructure layer. What do we mean by dedicated infrastructure layer? Means it's a, if we talk about in container world, right? So let's say if you have a service and service A is running as a container in a pod. So when we talk about service mesh is going to run as another parallel container which would be attached to your actual container. Now this container would be sharing all the resources with your service container, your actual container. So let's say all the volumes, the data, the networking, everything would be shared between these two containers. So in the microservices world, what we are doing is we are actually creating a parallel infrastructure layer. And now whatever communication is happening between services. So let's say service A to service B. If there is a call which is going from service A to service B, now that call would not be directly made by the service itself. The service will be attached to its app mesh or service mesh, and now this service mesh logic is responsible for doing the communication with the service mesh of another container. So each of the services would have a parallel, a container attached which will be responsible for doing all the networking between these two services. So we'll take a deeper look into this if it's still not clear. So now these service meshes which I'm talking about as a parallel container will be responsible for all the communication in and out of the service. Now service code will only be focusing on the business logic. So what we are doing is we are doing the loose coupling here. We are separating the service business logic into the actual code where service is running, and then we are separating all the networking logic, for the circuit breaker, service discovery, failure to fault tolerance, resiliency, all of that logic is going to be running in a separate parallel container attached to this. So we have done a loose coupling. We have separated the business logic from the networking logic here, right? So again, now the best part about service mesh is it is language agnostic. What does it mean by that is when you use platforms like AWS App Mesh, you actually do not have to create a service mesh for each and every service based on its language. So if it is a Java based service, you don't have to create any code, you don't have to write any code to create this parallel container or service mesh. It will be automatically injected into your cluster. We'll tell you more in detail when we'll do the demo. But what I'm trying to say is it's completely language agnostic. You don't have to worry at all about what would be the language in which your network policies would be created, your routing logic would be created. It will be completely taken care by the platform which you are running. At the same time, it is fast, reliable, and secure because security is now handled by your, service mesh. Communication is handled by a service mesh, so it becomes completely fast. And at the same time, it is often implemented using a pattern called sidecar pattern. So let's take a deeper look into what is sidecar pattern and more details about service mesh. So one of the benefits, these are some of the benefits of service mesh. Firstly, now because we have separated the business logic from the networking logic here, developers can entirely focus on implementing their business logic, implementing and bringing out their business values instead of sitting and writing the code for service to service communication and doing the replication of the same code across multiple services. At the same time, what is also happening is because we have separated these two logics, now your application have become more resilient to downtimes. What do we mean by downtime is, so let's say if you have four versions of your services running, or four replicas of your actual application running, then service mesh would have the load balancing logic also. So it will be able to identify that a particular service health is down, it is no more able to handle the workload, and it is going to do the load balancing of the traffic across multiple versions or replicas of your services which are running. So now what is happening is, even if one of the instance of your service dies or two service instances dies, service mesh would be aware about it, right? And it is going to do the recovery of these services. It will inform your control plane cluster, and at the same time, it is going to distribute the load accordingly. It reduces the complexity because now you're only focusing on your business logic. It has abstracted and completely taken care of the networking logic for you in a separate infrastructure layer. It reduces code duplication. So, what do we mean by that? Instead of writing 10 to 15 different files of code just to do the communication logic or all the networking logic, you are focusing on business logic. Everything else has been added directly into a different infrastructure layer, and you don't have to write it. The best part is you don't have to write any code for that. It is faster development, testing and deployment of applications again become very, very fast. So these are some of the service mesh features that we have. Like service mesh handles circuit breaker for you, it handles service discovery for you, it handles the security for you. It is capable of managing load balancing, then dynamic routing. So let's say if your service is running two versions, like you have version 1, and now there are new enhancements or features that you have launched, but you don't want to completely remove the older version because you are still doing a live testing in your production environment, let's say, and you want to understand how the new version is performing. Are there any areas where bugs are coming, or it is not performing as per the expectation? So it may happen that within your production environment you might be running 2 to 3 versions of the same service, and while you are running that, you want to do a testing, and you want to divert your traffic according to the percentages. So for example, you because this is a new service which has launched, you are only diverting 10% of your traffic to the new version, and all the 90% of the traffic is still being sent to your older version. So how do we do this dynamic routing? That could also be taken care by service mesh on behalf of the service. Then access control, like authentication and authorization, which API calls are authenticated and authorized, and which should be allowed access to the service. That would also be taken care by a service mesh. Then observability, that means fine grained control and visibility into how your service should work. That would be taken care by service mesh on the behalf of the actual service which are. So, what is exactly a sidecar pattern? So, if you remember, I talked about one sidecar pattern when we were talking about what is App Mesh. So, App Mesh basically uses more often a sidecar pattern. What do we mean by sidecar is? So, let's say this is your pod, okay, or your actual virtual machine or your EC2 instance where your microservice is running as a container. Now, this is your microservice which is running, and this is a business logic. And we have separated all of the other logic of service discovery, load balancing, throttling, service routing into a separate container called as sidecar. Now, this container will be attached to this particular service, and this would be communicating with the service. So now all the service to service communication which is happening, it will not be happening directly. All the service to service communication are going to happen using the sidecar. So sidecar of service A would be interacting with the sidecar of service B. So these two services are never going to call each other's endpoints directly. All the communication through these endpoints would be taken care on behalf of the service by the sidecars, right? So sidecar takes overall traffic in and out. So all the traffic which is entering into your service and exiting. So all the ingress traffic and egress traffic, both will be taken care by sidecar on the behalf. If it is running, if you are suppose you are running a service mesh in a Kubernetes environment, and you are running your application as a pod, right, in container running in a pod, so then you will be implementing a kind of controller which will be working with your Kubernetes controller API, and it will be injecting these sidecars along with each service which you are running. We'll take a look at it deeply when we will talk about App Mesh and how it does it. Then, as I told you earlier, also that let's say if you're running your service in a pod, so in the pod, the IP address, right? The networking, the storage, and all the resources which are there available in the pod would be shared with the service and the sidecar. So sidecar would not be having a would be sharing the IP address of the pod. It will be sharing the storage which is allocated to this pod and to the service. So everything which is allocated to the service would be shared by the sidecar. And every time we are running a app mesh or service mesh within a Kubernetes cluster, do remember that your service and sidecar will always be part of the same pod. They can never be part of a different pod. They always have to and must reside within the same pod or the virtual machine. So at a high level, this is what a service mesh architecture looks like. Service mesh architecture, just like any other services that we take a look, like Kubernetes or RDS. So service mesh also is divided into two main categories. One is a control plane and one is a data plane. So control plane is basically responsible for the management of the sidecar. So any communication which is happening, how the sidecar should has to be injected within each service, the management of these sidecars, all of that would be taken care by your control plane. Whereas data plane is where the actual services are running, where a proxy or a sidecar is attached to each of these services. So you can see here, service to service communication is not happening directly. It is happening via proxies or the sidecars, and these sidecars internally are communicating with your control plane. So control plane is responsible for the management of policies, for the management of routing, logic, everything for these proxies. On behalf of that, it is done by the control plane. So data plane is where your actual sidecar proxies are created, which handles the communication between these services and the mesh. At the same time, if you look at control plane oversees all the policies and configurations of the data plane. But control plane itself is not responsible for any service to service communication. That service to service communication or the data layer, it is actually taken care by your data plane. Control plane is only managing your proxy containers which are running along with your each service which you are running, right? Now, one more thing is, just like any other services, like let's say we talk about Kubernetes or RDS, control plane is the one which is responsible for injecting each of these proxies or sidecars into your data plane. So that is where whenever a new proxy or sidecar is created for each of your microservices, it has to self-register itself with a control plane. So that control plane can take care and have the location details and under configuration details of each of the sidecars which is running across each of these services. Okay. um, and at the same time, control plane is also responsible for managing and configuration of each of these sidecar proxies. So it enforces the policies, authentication, and collecting all the telemetry data about each of these proxies which are running in your data plane. So at a high level, we have two categories in which your service mesh is divided. One is a data plane, one is a control plane. Control plane, as it says, is a master plane which is responsible for maintaining the policies and configuration of each of the sidecars which is running along with each of your microservices. Data plane is where the actual microservices and its sidecars runs. Okay. So these are various service mesh implementations that we have across the industry. The top service meshes which are currently running in the market. We have Istio service mesh, which is completely open source. Then we have AWS service mesh, which is a service mesh provided as a completely managed service by AWS. Similarly, GCP has launched its Google service mesh. Then there's another open source service mesh called Envoy service mesh, and Azure has its own service mesh called Azure Service Mesh, then Conduit Service Mesh. Similarly, Red Hat OpenShift has its service mesh called Red Hat OpenShift Service Mesh. And then we have Linkerd Service Mesh. So these are some of the top, providers in the market which are providing service mesh control plane for you. So we'll talk more about App Mesh now. We'll not be covering the other service meshes which are available in the market. So why AWS App Mesh firstly, and what is the use of it and how it can help us, right? So what we have seen so far is that every service mesh has two components: control plane and data plane. Now imagine if you have to write the entire logic of control plane and data plane. It will become too much for you to handle, right? You need to have some platform which can do the management and the which can create the whole control plane for you, which is capable of monitoring all the sidecars, and you can only focus as a developer only on writing the business logic, and all the maintenance of these sidecars or proxies of service mesh could be taken care by the control plane. So that is where in 2009 AWS announced at their reInvent a new service called AWS App Mesh. AWS App Mesh is an application networking mesh which is completely and fully managed control plane by AWS. What do we mean by fully managed control plane by AWS? Means when you create an app mesh using AWS, the app mesh that you launches, it creates a fully managed control plane for you. That means the policies and the monitoring and configuration of all the sidecars which you will be creating would be completely AWS responsibility. And as a user or a developer, you would only be responsible for maintaining or injecting these sidecars across each of your microservices. Now, the data plane for AppMesh is run you or created using open source Envoy proxy. So we just discussed that right in this slide. There are two open source platforms. One is Istio Service Mesh and another one is Envoy Service Mesh. So AWS supports both. AWS helps you in implementing Istio Service Mesh as well. There is a whole workshop on it. And at the same time, if you look at AWS App Mesh is an integration with Envoy Service Mesh. So it is built on top of Envoy Service Mesh. So when you create a AWS Service Mesh using App Mesh, you actually create Envoy proxies where a sidecar is created and injected across each of your containers which are running, or each of your services which are running. It standardizes the service to service communication. It simplifies the observability solutions for you, because when you create an app mesh, you can enable logging. And when you enable logging, you can integrate it with AWS CloudWatch, AWS Log Container Insights, and many other services which are native integrations of AWS. And these are the native services of AWS. So see, what happens is whenever you talk about AWS as a managed service, the best part which comes along with any managed AWS service is that it has a native integration with any of the different AWS services. So let's say for networking, we have VPCs, Route 53, DNS, all of these things which are readily available, and any of your AWS managed services have a native integration with all of them. Same time for security, we have IAM. At the same time, in order to do the logging and monitoring, we have CloudWatch, CloudTrail. For databases, we have n number of versions and different databases available. So what is happening is, when you use a managed service within AWS, the first benefit is you don't have to do the complete management. The management of the control plane will be taken care by AWS on your behalf. So you don't have to worry about the maintenance or running the containers or pods or VMs in order to do and maintain your control plane. Second thing is, as a developer, you don't have to worry about this entire management, okay, upgrades, versioning of the control plane. You are only focused on your code, you are only focused on running your application altogether, and everything else would be taken care on your behalf by AWS for you, right? So using AWS App Mesh, which is again integrated with open source Envoy, it gives you consistent communication across the services. It gives you fine grained and granular observability using our various services like CloudWatch, CloudTrail, failure isolation, and routing. Right. At the same time, you can use our load balancers like application load balancers and network load balancers to distribute your load across various services. So AppMesh manages your sub proxy configuration. So this is a high level diagram. So let's say if you have these many services running, you have 5 services running. Now each of your service would have an Envoy sidecar attached to it, which will be responsible for all the networking logic. And all these Envoy sidecars would be communicating with each other, and at the same time they would be communicating with the control plane, which is your AWS App Mesh. So you will create a control plane cluster called AWS App Mesh, and this App Mesh would be responsible for injecting each of these envoy sidecars across each of your services, and you are going to have one gateway envoy service also. Now this gateway envoy service would be responsible for external communication. So all the communication which is happening outside of AWS, like from the internet, whatever communication or requests are coming, it will be taken care by the gateway envoy service for you. And then gateway envoy service is going to send that traffic to App Mesh, and then App Mesh is internally going to send that traffic to each of these envoys which is running as a sidecar across each of your services. Okay. So AppMesh currently supports all the compute services which are available in AWS. So AppMesh is compatible with any of your Amazon ECS, like if you're running your containers across ECS clusters, with AWS Fargate, with Amazon EKS, with Amazon EC2 instances, like if you're running a standalone application, or if you are running OKD or a self-managed Kubernetes cluster, then also AppMesh is compatible with it. And then for Kubernetes, we have EKS as a service, which is running. So AppMesh is integrated with all the compute, options which are currently available across all the AWS services. Now, one thing is AppMesh is now generally available across worldwide. That means in all AWS regions, AppMesh is available. So you don't have to worry about checking if AppMesh is available in Bomb region or Hyderabad region or Singapore region. Now, under observability and traffic control, you can use CloudWatch, you can use CloudTrail, you can easily export logs, metrics, and traces. You can see the client side load balancing and routing. For container service compatibility, we have three options available, which is Amazon ECS, Amazon EKS, and AWS Fargate. And in order to have a compatibility, you can integrate the service directly running on EC2 also. So if you have a self-managed version of container or self-managed version of your service running on an EC2 instance, then also AWS App Mesh is capable of integrating with it. So let's take a look at in detail about how App Mesh works and what are the various components of App Mesh through which all this management and communication happens between the services. So at first point, if you this is very new for you and you have never went through any document or what is App Mesh, this could sound little tricky and you may get confused, but my recommendation is at the end of the deck I have given all the links. We have many public documentation available which will give you a detailed understanding of each of these components if you are not able to understand, but I'll try my best because this is a basis of using App Mesh. So if you have a clear visibility of what is App Mesh and how App Mesh works, then only we will be able to proceed with our demo and you will be able to create the workshop. So there are 5 components of App Mesh. As you can see, firstly, the application itself. Now the application in which all your services are running. So a logical boundary where your application services or your microservices are running, that logical boundary is known as mesh. Okay. Second component of App Mesh is virtual gateways. Now, what are virtual gateways? Virtual gateway, as its name suggests, is a gateway that is responsible for all the communication which is happening to the outside world, in and out. So, like the egress traffic and the ingress traffic, all of that traffic communication to your users or to your network load balancer outside of your application boundary will be taken care by your virtual gateway here. Correct? So virtual gateway is where you have the ingress rules on the egress rules. Then the virtual service. So let's say this is your microservice, service A. It is running in some pod or a container or a Docker container, right? So this is your microservice A. This is your microservice B. Now let's say when we create a sidecar proxy for or an envoy proxy for your microservice A, there are 3 different components which will be by default has to be created. One is a virtual service. Virtual service is nothing but a logical name which for your AWS service, actual service. So if it is service A, a virtual service will be created for this service A, and this will be having all the location details and all the logistic details about this particular service. Then we will be creating a virtual router. Now what this virtual router do is, this router would have all the routing rules. Okay, so let's say if you have to do a load balancing to distribute the load across various versions, so that logic of distributing the load across various versions, or checking the health of each of your services which are running and how the service is behaving, all of that is taken care by the router. So as its name says, it is responsible for doing the routing and matching all the routing conditions. Then we have a virtual node. So what is a name? What is this virtual node? Virtual node is a one where actually your service endpoints reside, right? So service to service communication, where the actual endpoint resides and the actual parameters reside, is where your virtual node is, right? So in this example, you can see service A has two versions of service A running. Let's say you have a account microservice and you have launched a new version of account service where you have added a new feature for it. Let's say GST was not added before, and now in your account details you have to add a GST detail. Okay, so when you are adding a GST detail, you have launched a new version of your service. So let's say service A has two versions, version 1 and version 2. So in that way, router would be responsible for distributing the traffic across version 1 and 2. Now, let's say you decide that you want to send only 10% of the traffic to the new version 2, and you want all your 90% traffic to still be going to version 1, because you are testing the version 2 how it is behaving. So that condition would be added in your virtual router here. Now, this virtual router will be responsible for distributing the traffic based on these routing conditions that you have mentioned, right? Now, once all of this structure is created for each of your services in the form of sidecars, the actual communication will always happen like this. Virtual service will communicate with a virtual router. Virtual router will send the request to your virtual node. Then virtual node is going to send the request to another service. Let's say service A needs to communicate with service B. So this is how it is going to happen. Users will send the request to your virtual gateway. Virtual gateway will send the request to service A virtual service. It will send to the service A's virtual router. Then virtual router is going to send the request to virtual node. And then once service A has received the request and processed it, let's say it wants some data from service B in order to complete the request. So in order to communicate service A to service B, this communication now will be happening between virtual node to virtual service. So virtual node will send the request to virtual service, and virtual service is going to send the request to virtual node. And in between, virtual router would be there. So this is how the whole communication happened. Now these are the top 5 components of any AWS App Mesh, right? In any AWS App Mesh, for every service or every microservice that you are running, these are the top components which would be always created. So for each individual service, you are going to have a virtual service, virtual router, and virtual node. So these 3 components will be running across each service. For every application or mesh which we are talking about, we will have a logical boundary which will be called as mesh, and for each mesh there would be one virtual gateway, right? So just understand, one mesh, one virtual gateway, and each service will have 3 components, which is virtual service, virtual router, and virtual node. Clear? So these are some of the definitions of each of these components which we talked about. As I've already explained to you, I'm not going to go through this again, but what my recommendation is that if you get a copy of this deck, do go through each of these definitions. And again, whatever content I'm presenting here, this is being taken from AWS public documentation only. So there is nothing which is not publicly available in any of our documentations. So all of this content which I'm presenting right now is readily available across all AWS documents and the blogs that we have. So don't worry, even if you don't have a copy of this deck, you can go through our documentation and you can find more detailed version of each of these components. So let's say these are the components. Now in order to create a mesh, it's very simple. This is a CLI command that you can run. You can just say AWS App Mesh, create mesh, give the name of the mesh, and then in the spec, what you do is, in the spec you actually mention egress filter. Why do we mention egress filter is because every AWS App Mesh only allows egress traffic from its virtual nodes. That means only the traffic which is exiting from the virtual nodes is allowed within your app mesh. Okay. So let's meshify an EKS application. We'll go through, we'll see a one demo application, what is the issue that we are facing with this demo application, and how using app mesh we can resolve it. So first I logically explain you the architecture of the application, the challenges that we have with this application, and how we are going to solve these challenges using app mesh. And then I'm going to walk you through a demo which I have created, because we are doing this session which is almost 1 hour session and not a workshop. I cannot show you step by step each and everything, but what I have done is I will walk you through one of the workshop so that you understand what all steps have been followed, and then I'll give you a demo of it. All right, so this is our application which is called as product catalog application. Now we are running this catalog application within EKS cluster. So in an EKS cluster, we have two microservices, which is front-end microservice, which is a Node.js based microservice, and one product catalog detail microservice, which is again a Node.js application. Now these two are running within EKS and under a managed node group, right? And then we have another microservice called product catalog service, which is created using Python. So the reason I chose this example is so that you get a flavor of Fargate, managed node group, EKS, and at the same time you can understand that this particular application is polyglot in nature, right? You can see two are in Node.js, one is in Python. So when we are going to inject the sidecars and voice sidecars, you will understand that it is so much language agnostic and no need of writing the code. So you will not have to worry about writing the sidecar code in Node.js plus Python. We are not going to write any code. You are just writing the code for each of these microservices, and AWS App Mesh will automatically be injecting your envoy sidecars across each of these services. So let's take a look at it. So as I said, this product catalog service is deployed in Fargate mode in a serverless mode, whereas these two services are deployed here. Now the challenge, if you see here, what is happening is how the communication happens. The front end service calls your product catalog service, right? Front end service is a service which displays your main product page, and this service gives a call to get the list of products from product catalog page. Now product catalog service gives a call to product catalog detail page to get the list of all the each and every product which is listed here in the database. So what is happening is front end calls your product catalog calls product catalog detail service. So this is how the communication is happening. Now the challenge is front end service is hardwired to make requests to product catalog. Product catalog is hardwired to make requests to product detail service. Now in what is happening is, let's say you see in this example that we have version 1 of product catalog running, right? Product catalog details sorry running. Now product catalog detail version 1 is running. Let's say there is a new feature that we have added and there are certain new columns that we have added, and now we want to launch a new version of product catalog detail, which is version 2. So each time we are launching a new version of product catalog detail, we have to launch a new version of product catalog also. What do we mean by new version is that this product catalog endpoint should be compatible with the new version also, right? So the product catalog service should be compatible with version 1 as well as it should be compatible with version 2. So each time there is a new version of product detail release, we also need to release a new version of product catalog so that we are able to support both the old endpoints and the new endpoint relative, which are version specific. So I'll give you an example. There is an API call which is happening for a product. Earlier, we were only maintaining the product details like the ID of the product, the name of the product, and the price of the product. Correct? Now there is a new column or a feature which we have added that for each product, we are also maintaining the, let's say, the location of the product or the photo of the product, that how the product looks like. This is a new feature which has been launched in version 2, and in version 1 it was only returning back two details. It was only returning back the ID and the product name. Now it is also returning the photo of the product. So every time product catalog is going to call product detail, so it needs to have two endpoints now. One endpoint which will give you only two parameters, another endpoint which is going to return three parameters. So in that way, we need to have a new version of product catalog service also, so that one version would be compatible with version 1 of product detail, and version 2 of product catalog is compatible with version 2 of product detail. So this is a challenge. Now what is happening is, because of this dependency, every time we are updating or releasing a new version of one microservice, we have to release a new version of another microservice also, which is quite cumbersome, right? You have to release a new version of another service altogether. Maybe that changes has not happened in this service, changes have happened in another service, but still, because of this hard wiring, it is becoming a cumbersome task. So how do we solve this? The solution is App Mesh. We are going to use App Mesh to simplify this architecture by virtualizing the product details service. So what we are doing is, we will add dynamic configuration and routing the traffic logic into your endpoints of the product catalog service. So what will happen is, in product catalog service, there would be there would be a versioning which will be a dynamic configuration and route traffic endpoints would be added. So in that way, what will happen is, now based on the routing logic and the routing conditions, a particular endpoint would be called and a particular response would be returned. So you don't have to worry about creating a new version of product catalog. You can have n number of versions of product detail. Based on the routing logic and the routing conditions, a particular request would be forwarded to the individual nodes and the response would be received. How do we do that? Let's see. So this is the architecture that we would be creating once we add the envoy proxy to each of our services. So this is EKS, right? We have this logical boundary called product catalog mesh. You can see this pink line. This is a logical boundary which we called as mesh. Now inside this mesh, we are going to have three microservices running in pods. So one microservice is front end, another one is product catalog detail, which is version 1, both of them running under managed node group. Then we have Fargate profile, in which we are running product catalog service, which is a Python service. So this is your application code. We will be injecting an envoy proxy, and we will also be installing an X-ray agent in order to trace the request which is going from one service to the other. At the end, what will happen is, this pink line, which is called as product catalog mesh, this is something which would be managed by App Mesh control plane. So we will create a new App Mesh, and that App Mesh control plane would be responsible for managing all the envoy proxies which are running parallel to each of your microservices. Now for visibility and observability, we have installed X-ray agent on each of these services, so that all the logs could be sent to CloudWatch and X-ray, and we should be able to observe the performance of each of these services. Okay. So these are the App Mesh components that we would create, right? So if you look at it, for product detail, this is a mesh. We will create a virtual gateway. Now virtual gateway, we will have n number of envoys which are responsible for routing the traffic, external traffic, to the actual services, right? Now we will have, let's say we have a product detail page and we have a product catalog. So we know that product detail page is a one where new version is launched. Let's say we have version 1 and version 2. So what we will do is, we will have virtual service, which will be a representing the logical microservice of product detail. We will have a virtual router, and it will have the routing logic, that whether it should send the traffic to version 1, or it should send the traffic to version 2. Same way, product catalog service, it will have a virtual service and it will have virtual node, where your actual application container and your sidecar envoy would be run. So this is at a high level the architectural components that would be required in order to create this whole mesh for this application example. So there are certain prerequisites which I have already done. So first thing is, I would request you all to have a good understanding of App Mesh components. Although I have briefed you about them at a high level, but there are many more fine-grained details which you might want to understand when you are actually implementing App Mesh in your production environment. So do take a look at it. We are assuming that you already have a good understanding of Kubernetes and EKS. If not, I have given the links here, and there are many videos, YouTube videos, and tutorials and blogs available, and which are released by AWS. So please go through them. Another thing is we need AWS CLI, because this entire workshop that I'm going to show you, we will be doing it from CLI instead of console. The reason I always prefer CLI compared to console is because when you do anything from console, it is a manual task firstly, right? You have to write each and everything, you have to type each and everything, so it becomes manual and time consuming, and at the same time you are not able to replicate the same thing. So let's say if you create EKS cluster using console in your dev environment, now you want to create the same one in your production environment. If you have to manually do it using console, it will take a number of time detail to put in each and every detail, and at the same time you cannot replicate, so there is a probability of human error. So whatever workshops I do, we usually prefer to use a CLI version instead of the console version. But I will also be showing you that how in the console each of these components looks like. So what you can do is whenever you create any of the resources in AWS, try to create them using CloudFormation templates or CLI, and you can verify or manage or control them using the console component, right? Another package installer that we would be using is Helm. So we will be using Helm version 3 or 3.0 or later for this particular workshop. So how do we get started with meshifying our app, this product or catalog app using AWS App Mesh? So the very first step is we are going to install App Mesh controller. So I gave you that command. We will just create an App Mesh controller. You can create it from CLI, you can create it from console. Second step is we are going to create a mesh inside the Kubernetes cluster. So in our EKS cluster, we are going to create a mesh. Mesh means nothing but a logical boundary which will be communicating with your App Mesh controller. Third thing is we are going to create all the other components that we talked about, right? We are going to create a virtual service. We are going to create virtual nodes. We are going to create virtual router. And then the last step is we are going to create namespaces so that these nodes and components of App Mesh are able to communicate within the same namespace where your application is running. So one interesting fact I want to tell you about is when we talk about AWS App Mesh controller, it actually injects and behaves more or less in a similar way like your Kubernetes control plane. So as you know, when you talk about Kubernetes control plane or EKS control plane, the control plane being the master plane is responsible for all the communication and API calls which are happening between the control plane and the data plane. So in a similar fashion, this App Mesh control plane actually becomes a Kubernetes controller. It adds itself as a Kubernetes controller within the controller plane of Kubernetes, and this controller then is responsible for all the API communications which are happening with your envoice. So what you can do is you can automate the injection of these. Once the app mesh is created, it is enabled as a controller within your Kubernetes cluster or EKS cluster. Then this controller is basically responsible for injecting these envoy proxies across each of your services. So it automatically gets injected. You don't have to write any code for that. So let's take a look at it in detail. So I'll quickly share my screen again. So if you see, let me quickly log in back. My session has expired. So this is the application that I was talking about, right? Which is already running in my environment. So what I've done is, because this is already deployed, this is the architecture. We have version 1 and version 2 of catalog service running, catalog detail service running. The product catalog is running in Fargate. These are the, endpoints which are being communicated, and the 50% of the traffic is going to version 1 currently, and 50% of the traffic is going to version 2. You can see currently which version is running. So let's say if I run this multiple times, it could change from version 1 to version 2 as well. 1 minute. So let me hit it. Now you can see when the load has increased, now the product catalog version 2, so this particular URL is now being managed by version 2. If you see Fargate, this product catalog service is maintaining the product catalog of all my products. So these are the list of products which are there. Let's say I want to add another product to it. I simply say table chair. Let's say I add a product called fan. I simply click on add. You can see the fan ad has been added as one of the products in my product catalog service. So this is a very simple, quick application that I'm talking about. So from where I have created this application, again, because I wanted you all to have a copy and you should be able to replicate this entire example in your own AWS environments as well. What I've done is I have created this using EKS workshop, right? So you can see this EKS, www.eksworkshop.com. This workshop uses this particular example. So it has all the necessary steps. So you can go to introduction, you can start the workshop. It will tell you what all necessary steps are required in order to start creating your workshop. For this particular example, when you create it using EKS workshop, I have used Cloud9 as my ID. But if you are not comfortable using Cloud9 as the ID of AWS, you are free to use any of your own IDs, like any of the IDs that you are comfortable and running on your local machines. So when you go to start the workshop, it gives you list of all the things, right? How to create a workshop, how to install the Kubernetes tools, which Kubernetes tools are required, how to set up your IAM roles, right? How to clone the repositories. So these are 3 public repositories which are available. Okay, so you can go to GitHub and you can see the EKS workshop here. All of these are open source and they are completely available for you. So you can see this ECS demo front end, ECS. So these are the 3 microservices which we are talking about. So this is one of the EKS workshops which I already had configured. So I went ahead. So what I've done is I already had my EKS workshop running with some of the services. So if you go to the advanced version here, this advanced, right, you will see there are 2 workshops available. One is service mesh with Istio, but because we are not focusing today on Istio, our main focus is on app mesh. We will go to app mesh, but this is also available as an option. Let's say instead of app mesh, you want to see how you can use Istio as a service mesh within AWS, then you can go through this workshop. But today we will only focus on this, which is service mesh using AWS App Mesh. So I've completely followed this workshop, and believe me, there was not a single error. You can go through it very simply and very easily directly. All right. So AWS service mesh using App Mesh. So what we have done is, this is the product catalog application which I just show you. We are going to create this entire application. So what we have done is, there are simple steps that we have done. Some of the prerequisites, like you have to configure your region, account ID, AWS CLI. So all of this configuration, which are the preliminary steps. And second, we are using this particular repository. So I'll quickly show you this repository so that. So this is an EKS App Mesh polyglot demo, right? Which is using the product catalog microservices, and this is the architecture that we are going to implement. So once you clone this repository, right, all the files would be directly created. And for this particular thing, we are using Helm as a package installer. So we are going to install Helm, and then we are going to create one Helm chart here, right? We are going to create one load balancer here. Okay, now this load balancer would be responsible for communicating and entering all the traffic to your EKS clusters, right? So let me quickly show you what all things are there as part of. So if you go to deployment, because this is an EKS, so all the YAML files which are required in order to create your cluster. So everything, this cluster would be created firstly using CloudFormation scripts. So this, when you run this, it basically runs this base app.yml. Now this base app.yml is the actual uh, you know uh, baseline CloudFormation script that would be run, and this would be responsible for actually creating your app mesh along with your all the services in it. So these are the microservices which will be first created. Okay, so these are the steps. We first clone the Git repository. Once we have cloned the Git repository, the next step we have to do is we will be associating an OIDC provider here, right? OIDC provider is first setup, which is an IAM OIDC provider. By default, this OIDC provider is not enabled in your clusters. You have to create it first using EKS CTL. So you you create and associate an IAM OIDC provider with your cluster, which is the cluster name EKS Workshop EKS CTL. Once you have enabled and associated an IAM OIDC provider, you are going to create a namespace. So we have created a namespace called product catalog NS, right? Namespace, if you know, is a virtual space which we create for association purpose, so that all the resources which are running together are logically minded by that particular namespace. So we create a namespace, right? Then we create two IAM policies. One is the IAM policy for Envoy, that means which will be used for all your Envoy proxies which is running across your services. And then we are going to create an IAM service account. So if you know the concept of service accounts, we usually have two kind of accounts, right? One is the account which is very much human specific user accounts. Now, when we need the service to service communication, we need the services to have authorization and authentication happening with the API servers and the other services. We don't want any user based account to be used for that. So, that is where Kubernetes allows the use of service accounts. Now, this service accounts actually help you in all the security part of it and authentication and authorization with the API server also. So what we'll do is we will create a IAM service account for this EKS workshop that we have created, right? Now, once this policy is created, once the IAM account is created, what we are going to do is we are going to create a Fargate profile. Now, Fargate profile is where your actual product catalog microservice will be running as a Python service. So very simple Fargate profile. This is one of the YAML files which we will be using. These are Kubernetes YAML file configurations. So we'll create a cluster configuration, right? We'll give the name of the cluster in which we want to launch our Fargate profile. We'll give the region, and then we are going to give the name of the Fargate profile, the namespace, which is product catalog NS, because going forward, all the components and services that we are going to launch, we will be launching it in the product catalog NS page. And the application name is product catalog, correct? So we'll just go to the folder and we are going to apply this Fargate profile. So that Fargate profile is now created. That means a Fargate instance is launched for your application. Now, once all of this is done, we are going to see if the Fargate profile is created or not. Once you run this command, you will see that a Fargate profile would be created. So what I'll quickly show you is, this is a Cloud9 environment which I have. Let me quickly log in again because my login has expired. So if you see, I have Cloud9. Okay, and if I go to the EKS workshop, so best part about using Cloud9 is it launches upon an EC2 instance, and you can say that this instance is not continuously running. It automatically stops after every 30 minutes or 1 hour duration, whatever duration you give. So in a way, you are not paying for the Cloud9 environment to be always running. It will only be running when you want to use it. Otherwise, it will automatically stop. So this is my EKS workshop, which I was talking about, right? This is a workshop folder where all my files reside. Under this, I have created this another service, or which is called as Polyglot demo, right? In this, you can see the three applications which I have: catalog detail, front end node, and product catalog. Under deployment, you will see these are all the YAML files which we are going to use in order to create this workshop and deploy, right? So base.yaml file which I was talking about, this is the basic CloudFormation script which will be used in order to launch our three microservices. Okay, and then I talked to you about Fargate profile, right? So we will have Fargate profile. 1 minute. Yeah, workshop CTL. It's in deployment cluster config.yaml. So if I go here to cluster config.yaml, this is my file. So you can see this is a Fargate profile which I have applied. Now let's say if I run this command to see if my Fargate profile is already running. So I am simply run this command here. Okay, so these are the subnets. It has launched 3 subnets in a private subnets where my product catalog service is running, right? So these are the steps that I have done. I'll quickly show you. If I go to EKS, this is a cluster that I have created. So I've currently created EKS workshop as a cluster. So you can see this EKS workshop, EKCTL, right? And you will see these are the resources which are created. So it has n number of pods which are running, one for App Mesh and one for the CloudWatch and one for other agents. Same way I have deployments. So I have App Mesh controller, I have core DNS, which is internal to Kubernetes system. I have CloudWatch agent running for Prometheus. I have the other services running along with product catalog, product detail, and my front end support, right? So these are the 3 microservices which are already running, correct? And if you look at the networking component or the add-ons, uh, logging, if you see, I have enabled logging for all the control plane. And in terms of compute, see this Fargate. So one is a Fargate profile which is running. You can see this Fargate profiles. So if I click here on the Fargate profile, and these are the node groups. So there are 3 managed node groups which are running where all the other microservices are running, and product catalog is running on Fargate profile. So this is my Fargate profile, right? And these are the pod selectors which are running. So product catalog is one of the service which is running here. And this is IAM which I have created. So as I was telling you, I have created a service account in order to do the management with and communication with the API servers for authentication and authorization purpose. I have created a service account. So this is my service account that I was talking about. So once we are done with Fargate profile, we are going to create the another IAM service account for your CloudWatch agent, similar to the one we created for Fargate. Then once we are done with this, I'll quickly move on to the next step, which is Meshify. So let's say all our cluster is installed, the EKS cluster is up and running. Now, what is the next step? So as I told you, when we are doing an installation of the app mesh, there are certain components that we will have to create. We have to create a mesh, we have to create a virtual service, we have to create a virtual node, virtual router, virtual gateway. So how do we do that? So this is a overall diagram which we were discussing, right? Every service is going to have a proxy, and it will internally have a virtual service, virtual node, and virtual routers created. So let's see how do we create them. So first we'll create a Helm chart. So this is how you create an Helm chart. Then we are going to install App Mesh controller. That means this is a step where we are going to create our App Mesh. Okay. So you create your App Mesh, right? Create the policies, create the IAM role, and then finally we are going to upgrade our App Mesh controller. The App Mesh controller is created. So I'll quickly show you how the App Mesh controller looks like. So if I go here and type App Mesh, once you create an App Mesh controller, an actual App Mesh gets created here, which I have associated with the service account. So you can see this product catalog mesh. Okay. This product catalog mesh is the app mesh which I have created, which is associated with my product catalog application. So this is a mesh. This is a mesh name that I have created. This is a mesh ARM. It has egress filter. That means it deny external traffic. It only communicates and handles the internal traffic. Okay. And then once my mesh is created, okay, I'm going to meshify my services. So how do you meshify your services? You are going to create n number of components. So this is how we are going to have front end service will have a virtual service. Similarly, virtual service will communicate with virtual node. The front end node will communicate with product catalog will communicate with product detail. So each of these services has n number of components, which is virtual node, virtual service, and virtual router. So we are going to create virtual router only for product catalog and product detail. Currently, we don't need a virtual router for front end service. All right. So how does the configuration of each of these looks like? One is you. This is a YAML that you will be creating. Okay. Now, in order to create a mesh, this is a simple. You will give the namespace. You will give the name of the mesh, which is a logical boundary. The very first step is you will create a mesh. Then you are going to create individual virtual service, virtual node, and virtual router for each of these services. Right. So first you create a virtual mesh, then you create a virtual node. This is a configuration for virtual node. Let's say we want to create it for front end node. We give the namespace, we give the name of the virtual node that we want to create, right? We want to give the pod, in which pod it has to be running and what it is associated. So it is associated to front end node where your actual microservice is running. You give the port mappings, right? All of these details. Then we create a virtual service and virtual router. Okay, so this is how you create your virtual service. Okay, in this virtual service, again you are going to give which virtual router you want to use, what is the configuration of the virtual router. So this is going to be a virtual router configuration with the port, right, and the targets and the weight, like how the traffic should be. So let's say we are currently launching only one version of product detail, right? So 100% of the traffic will go here. Now let's say you have launched another version of product details, so you will say weight. So in weight you can say 10% to version 2 and 90% to version 1. So this kind of logic will come here in weighted targets. You simply click on mesh.yaml and apply this deployment. Once these deployments are created, all your meshes would be created. Okay, and this is how. So I'll quickly show you this, that how these are running. So if I run this in my Cloud9 environment, okay, you can see this. These are the actual meshes which are running, right? These are the I'm just trying to understand. Uh, these are the routers, correct? These are the two routers. I think one of them is a node, three are the nodes, and three are the services which are running. So these are the various components which are running in your service. So yeah, we can see product detail version 2, product detail version 1, right? And this is your service, and these are your nodes. So each one node will be associated to each version, whereas one service would be created per service. So this is how your uh, all the components are created. Okay. So if I go back to App Mesh, I'm not sure. So you can see here, I have virtual services. So these are the three virtual services which are running: front end, product catalog, product detail. If I go to virtual routers, there are two routers which are running, one for product catalog and one for detail. So these are the two routers which I have created. Virtual nodes, as I said, one node will be associated to each version. So you will have front end node, you have product catalog, and because we have two versions of product detail, we have product detail version 1 and we have product detail version 2. So each version would have its associated virtual node, which will have the details of the endpoints which will be used for communication purpose, right? So this is how your entire mesh is created. Now when you want to create the gateway, again these are the steps which you can do. Because we are running late right now, I'm just going to show you quickly. This is a YAML file for virtual gateway which you can use. Okay, once a gateway is created, you will be able to see your gateway under virtual gateways, and this is a gateway that I have created. Now this gateway will be actually used in order to do distribute the traffic. All the internet traffic which is coming from outside would be taken care by this virtual gateway here. Okay, Um, so I think this is where we end our demo. You can do a testing. So whenever so I'll just give you an example that whenever so what we are doing is we are exporting the load balancer here, okay, and this is a load balancer and this is a product catalog service. So let's see how the communication happens, okay. So for example, product detail, we want to understand how the product detail is coming. This is my load balancer. Now I'll quickly go to a CloudWatch so I can show you how the observability happens for each of these and how the map is created. A beautiful map gets created because I have installed X-ray agent in each of these services so that we are able to trace how the request is going from one service to the other. So I'll quickly show you that as well before ending the session. So if you see when you go to CloudWatch, you would be able to see that this is a EKS cluster that I have, right? Okay. Now, in each of these EKS clusters, if you go to log groups, a log group would be created for each of the services that I am running right now. Can you see this? EKS workshop, EKS ETL application, then data plane, then the host and the performance. Prometheus, because I'm running it for as a agent or a separate container in order to monitor the logs. I have EKS ETS cluster, then Fluent Bit CloudWatch in order to monitor the CloudWatch. So let's say if we go inside each of these, if we go inside data plane, so you will be able to see all the logs related to data plane. Let's say you want to understand the logs of your Fargate. So this Fluent Bit CloudWatch is representing your Fargate. So you will be able to see all the Fargate related logs for product catalog service here. These are my log streams, right? You can see slash product slash ping. So whenever we are linking our product or querying our product, this service gets called. Same way in application monitoring, if you go to X-ray, you will be able to see the service map. So beautiful service map gets created. Can you see this? So client goes and calls your app mesh proxy, right? Then we have product catalog and the front end node. Then we have product catalog here, right? So or version 1. Then we have product detail version 2. So all of these map gets created for you, and you can see that each of these services. So let's say if I click on this and I want to understand the gateway logs, so I can very easily see all these gateway logs and its latencies, requests and faults. I can click on view traces and I would be able to see how the request is going and coming from each of these services. So front end may how much time it took, then product catalog how much time it took in order to complete the request. So all of these traces are visible for you, right? So once we it's very simple, 3 to 4 steps are required in order to just enable the CloudWatch agent and X-ray agent. And once that is done, all these traces becomes very very easy. So if any troubleshooting has to be done, you don't need any other a tool to be used. You can simply use AWS X-ray analytics and all these tools in order to understand how your request traversing is happened, and tracing becomes very very easy for you. The same way, because I've used Prometheus, you can see all these Prometheus related details also comes in. So when you create on service map, you would be able to see your service map which is created. This is the service map which I was talking about, right? And you can see how the time is taken. So when the client requests and goes to your gateway, this is ingress gateway that is created for your product catalog service. The gateway service then sends the request to front end, right? The front end sends a request to a front end node. Then the front end sends a request to your product catalog service. It sends to the product catalog node. Then product catalog sends a request to product detail. Product detail has two versions. One is product detail 1, one is product detail 2. Now if you click here, you can see this, right? Under each thing you can see this AWS App Mesh proxy. That means the request is actually going to the proxy, and proxy then sends a request to the product catalog node here. So every time a new request comes in, that request is basically coming to the proxy and not directly to your application service, right? So every time a new request comes to gateway, or whether it is coming to your front end node or your product catalog, it basically goes to your proxy node here. And you can also see the time which is taken, right? What is the average response time for each of these services? So this is all about the app mesh and how you can use app mesh. So my going back to the deck again, these are the call for actions which I would request you, if you don't have a basic understanding of Kubernetes, go through this link, read more about it. If you don't have a basic understanding of what is AWS EKS and how does it work, we have given you links. My recommendation is please go to eksworkshop.com. It's a very, very simple and very detail oriented workshop which you can do it in your any AWS environment. And then there is a new workshop which is created, which is called appmeshworkshop.com also. If you are very, very interested in being getting a very expert level understanding of AppMesh and doing the workshop for AppMesh, then my recommendation is to go with the appmeshworkshop.com. These are some of the reference resources which you can go through, which I have used to build all this workshop that I have created today. So that is it for today, and here we end the session. So we are opening the floor for Q&A now. So if you have any questions, I'm open to answer them. Thank you
Thank
guys. Thank you so much for joining.
Thanks, Mahima, for that wonderful session and giving us and walking us through with the demo. Thank you so much. I think there are many questions what we have, so let me quickly bring up a couple of them. So the first one that starts is when you were talking about the sidecar, right? So doesn't this extra interaction via sidecar introduce more potential point of failures?
No, actually, because Sidecar is only managing the networking logic, and the maintenance of the sidecar container is also maintained by app mesh controller. So as I said, this controller is basically responsible for the management of your envoys or sidecars. So if any time, let's say, the container in which your sidecar is running fails, then that information would be going to your app mesh controller plane, and the controller plane will take care of creating a new sidecar container and to manage all the traffic. So all of that high availability, resilience, all of that would be taken care by your app mesh control plane. So you don't have to worry about resiliency or fault tolerance of your sidecar container itself. I hope that answers your question.
Yep. Yeah. We'll move to the second question. So this is around when you're going through the architecture and all. So a couple of people were curious that there are too many components what we have, and when it comes to Kubernetes, right? So would this be simpler that we go with modular monolithic, or microservice via Kubernetes and Sidecar is the way? What's like which will be the simpler to implement?
So I think I'll answer it very in a different way, right? So not everything fits everywhere. So same way, Kubernetes might not be the right technology for every microservice container workload that you are running. If you think Kubernetes is too complex and your application is not very huge, right, and not very complex, and you don't need so much components for your orchestration, then my suggestion is go with ECS. ECS is much simpler to use compared to EKS. And for beginner level, if you are a beginner and you have not used EKS before or Kubernetes before, ECS would be the right approach to start your journey on containerization. Now, second thing I would like to iterate, which I think forgot to mention, and this question has reminded me that uh, it is not mandatory that you should be using AppMesh across each of your container workload. AppMesh might not be helpful in scenarios where the size of your application is small, or where your application is very chatty in nature. What do we mean by chatty? Means there is too much of communication to and fro which is happening between the services. Let's say if you're making 4 to 5 calls in and out to and fro with the other services in order to complete the request, then AppMesh might not be the right technology here. The reason is because if the application is very chatty in nature and so many requests and recalls are happening with your each microservice, then lot of bandwidth would be there because to communicate between these sidecars, and it may happen that the network latency could be introduced whereas these issues have now been resolved to a great extent. These issues only comes in when you are not using a service like App Mesh and you are creating your own open source Envoy or Istio. You might have to manage these network latencies, but when you are running all of these components with AWS App Mesh, most of these network latencies and other things are taken care by AWS. But just one point here, that you have to design your application accordingly, that there's not too much of chattiness, because it might introduce network latency for you.
Got it.
Okay.
Makes sense. And also, I think as Mahima mentioned, right? So is I mean, I've also experienced it. Kubernetes will not fit everything. It also depends what kind of resilience you need in your architecture. So when it comes to modularized, monolithic versus complete microservices, it all depend what kind of application and how that application will impact if there is any sorts of failure in your business. If it is not highly traffic, then you still have it. But if you need live, like something you can talk about, maybe a government website like Aadhaar OTPs and all, which needs to run 24/7. So you need to leave like a highly resilience architecture which needs to scale up. So it depends on the kind of architecture and business application too.
Correct.
Another question is, do we need app mesh in Fargate, which is from Karthik?
Yes, we need AppMesh in Fargate as well. The reason is we are separating the cloud, business logic from networking component. If you are suppose not using AppMesh, okay, and you are simply running your microservice within Fargate environment, then you will be responsible for adding the networking logic of service to service communication. All the services which will be running in Fargate, although the maintenance of your nodes and or because Fargate being serverless, you don't have to worry about the maintenance of the nodes or capacity management. But all the other things related to your code and all the challenges which we talked about still remains the same. So when either you are using Fargate or you are running your service within a managed node in EKS, the networking technology of how the networking and the service to service communication will happen, all of those challenges will still remain the same. If you are not using AppMesh, then you are responsible for writing that entire code within your microservice code itself. So the whole point here of using AppMesh is to avoid writing the duplicate code of networking logic within each and every microservice. So you don't have to rewrite that code in each service here, because Fargate is only solving your. It's a serverless technology. It is not inherently solving any networking challenges on your behalf.
Correct. Makes sense. Another question is from Ajay. Does app mesh works like STO service mesh?
Yes, more or less same. But Istio is again an open source technology. Inherently, if you see all these app meshes or service meshes which are created, the sidecar pattern and the actual pattern in which they work more or less is same. But app mesh is integrated with Envoy rather than Istio. But Istio is also one of the standards in the market. If you are interested in trying out Istio, in EKS workshop itself, we have another link that how you can use Istio as a service mesh along with AWS. So do try that out.
Cool. Also, I see one question where people are like, we are beginners and we want to start. We don't have much experience on DevOps or Kubernetes. I think Maima already answered that as a call to action by giving the link. So you can follow the same to start with fundamentals of Kubernetes to deploying the entire demo which Maima presented us.
Right. So, guys, n number of articles are present. I've already given the links. But if you go to internet, I think I have found one of the courses on Udemy is to be very very helpful at a cost of approximately 300 to 400 rupees. And that's a beautiful course on Kubernetes. So do try that out. And Other than that, also there are a number of tutorials and videos available on YouTube which have been done by AWS experts, so you can follow them also.
Thanks. The next question we have is, AWS API gateway transform the response payload. Can we do this with app mesh as well? Say that service B, we to change the response and I don't want to update service as a code, instead use Envoy proxy to transform response from service B. Is that possible?
I would not suggest you to replace API gateway with Envoy, right? These are two different things, and each of these have a different capability here. Now, API gateway is not only responsible for transforming your payload, right? API gateway is doing many more functionalities for you. So let's say it behaves as it gives you throttling, it gives you routing, it gives you proxy. But other than that, also there are many other features that are provided by API gateway. So we cannot completely replace our app mesh with API gateway. There are some of the functionalities which are added by app mesh gateway, right? We have seen there are certain components that we create when we create a app mesh controller along with the setup. So app mesh gateway is one thing that we create which communicates with your load balancers or API gateway, but you cannot replace an API gateway with app mesh. App mesh provides you with a different functionality compared to your API gateway, but there is some overlapping, so I would not deny that.
Cool. The next question is, in the demo which you presented, uh, Kalyan wants to know why you use NLB.
All right. So, no, I think we have used ALB and NLB both, right? ALB used for internal load balancing and distributing the traffic across multiple services. NLB is basically used for external traffic. So, if you know about the difference between network load balancer and application load balancer, network load balancer is mostly external facing. That means all the external traffic which is coming into your system goes through external firewall, and then firewall sends it to external load balancer, which is a network load balancer. So network load balancer does not have all the logic of routing based logic, whereas your application load balancer has all that logic. So network load balancer is only used as an external load balancer here. It is not used for routing the traffic or distributing the traffic across multiple services. So network is only for external facing, whereas application load balancers are used, which is used for internal load balancing across various services. So we have used both. Uh, Unfortunately, I did not get so much time to go through each and every component. There are multiple components which are created. But if you try out this workshop, you will be able to see all the components which are created. So I just recommend try this workshop. It will hardly take 1 hour to set it up, and you can see how it works.
Got it. Uh, I think the previous question which we asked, right, which was around the API gateway, I think the question from the audience was not to replace API gateway, but if the response transformation capability that API gateway has can be implemented by App Mesh too.
Mm, I think we would need more detail to answer this question, because I would like to understand what kind of response transformation we are talking about. Currently, AppMesh is not capable of very highly advanced features here. What AppMesh Gateway is doing is it only managing the routing of the traffic. So all the external traffic which is coming in, it is routing to the different envoys which are running across each of the services. So it is not exactly doing the job of an API gateway here. So there's a whole lot of difference between them. But the answer is no. API gateway's capability like transformation of the response and all would not be taken care by your app mesh gateway here. But I will still need to go through in detail, because I'm not 100% sure on this. If there is a capability for app mesh gateway to do any kind of transformation, so I can get back to you on this. But to my best knowledge, that is not possible right now.
And also, just to add, right, it's not even recommended that you do that, because once you do the app mesh and you try to add some transformation, in the long term, it's more like a hack thing, right? Hack in a way, like you're doing a patch for now, temporary patch, so which is fine, which can be good. But if you're looking more from a sustain or a consistent architecture, then it is always good that you get everything in your response class or interface. So that helps you from a documentation of your coding application standpoint also. So in, let's say, if think you have everything at one place centralized, it will help you to modernize or make the changes in the future. That's the beauty of microservices, right? That you can update it, you don't have to worry about it. You don't want to build something like monolithic where you have 15 different things segregated at 15 places. and then it becomes quite mess that what you want to do. So that is also another way from an architectural standpoint. One is the capability, obviously we'll get back to you, but from an architectural perspective, it will be always good that you follow that proper structure which help you to scale, not get blocked, right, for making the new changes.
So another point on top of that is API gateway. If you talk about, you can add some coding logic over there. When you're talking about the envoys or the proxies, we are automatically creating it. We are not writing any logic there, right? So you will not be able to write any fine-grained response transformation logic within your envoys. You can write it either in your business logic, or you can write it. I mean, some of the routing conditions that you can write in your YAML files that we are creating when you are creating your routers or when you are creating your nodes or services. But apart from that, you are not writing any code. So any transformation which has to happen, that kind of business logic has to go somewhere. But envoys are not giving you or providing you a facility to write any business logic or code. We are not writing any code here.
Yeah. Moving to the next question, is sidecar pattern still a thing? There are new service mesh and CNCF projects using your. There are CNCF projects available. Is that on AWS roadmap?
Sorry, yes, that is on roadmap, but currently this is what we have in our latest reinvent. Also, there are no such announcements which has been made so far, but you can know about the roadmaps on our website. So if you go to AWS website and if you want to know fine grained detail about what features are going to be implemented for CNCA project, you can take a look at it. But frankly, I don't recall or remember some of the roadmap items which are there related to the CNCF project. But if you want details, there's a link available, you can go through that.
Got it. The next question is, what are the header requirement CPU memory per container in large cluster would impact in terms of the capacity, from Ajay?
Okay, Ajay, so again, the capacity requirement, CPU memory per container, that completely varies as per the application requirement. You may have a application container which is running. Let's say you are running a container of a tool, you are running a database as a container, you are running uh, a standalone service which requires a lot of memory and CPU. So in that case, container size requirements would vary and the hardware requirements would vary for your cluster compared to a very small application which is only doing one or two API calls. So again, this is a question which will vary as per the requirement of your application and not as per the requirement of the containers. So containers, occupy the space which you are specifying as part of your image and as part of your configurations. So it completely depends on your application and requirements here.
Cool. And yeah, Jay, I think as Maima mentioned, right? So even if you take like machine learning versus a microservice, in that case itself, the CPU memory or GPU requirement would differ. So it will be depends on what exactly you're trying to solve or trying to deploy in that Kubernetes application. So I think that's what we have. I think one question which was on the NLB, right? Mahima, at the beginning, what we mentioned. I think what Kalyan is saying in the diagram, he can only see one source and one destination, I think, in the architecture. So Kalyan, what we will do is we'll share the presentation. I'll upload the presentation as a user group Slack Mumbai channel. I will also share the similar and the YouTube channel at the bottom in the comment, so you can have a look. And still, if there is any questions, you can reach out to me on LinkedIn or Mahima on the LinkedIn. We'll help you to take that question offline.
Yeah, we can do that. You can reach out to me. I'm also part of the Mumbai user group Slack channel. So you can ping me and we can do a deeper discussion on this.
Cool. So I think that's more or less what we have all the questionnaire. Thank you so much, Maima, for spending your weekend with us, giving us a walkthrough about App Mesh Kubernetes. I think this is one of the very hot topic nowadays when anyone is looking to build a product or any sorts of microservices. So thank you so much. We will request you to please stay online. There is a quiz which will be there for all the active participants. So I'm sharing the link. We will request you to please register for the quiz. which will all the registration will help us to ensure the winners as well as get back to you for the credits. So please do register. I've shared the link. I will get my co-volunteer also here, Tejas, who will help us to play the quiz. So please start registering the quiz. We'll start the quiz like in few minutes, and Maima will be with us. Okay, she cannot play the quiz because she has designed it, so she cannot play it, but she will be with us. So if you have any questions, you can put it in the chat, the final rounds of questionnaire, and I'll pass it on to the Tejas for the quiz. Tejas, over to you.
Yeah, thanks, Anjit. Okay, let me share my screen. Okay, so let's wait for 2 minutes for everyone to register and get to the quiz page. This is the quiz link. The quiz link will be in the comments in the chat section, so you can register and be ready for the quiz.
So I can see there are 10 registration what we have. I would request everyone to please register for the quiz as soon as possible so we can start. We'll wait for 2 more minutes before we start the session. Yeah, you can see Tejas as well as me in the session. Again, we are just here to from the leaderboard perspective, but we are not allowed to play the quiz. So don't worry.
Yeah.
This will be pure fair game for everyone.
Okay, so those who are new to this platform, let me give a quick introduction of this. Okay, so the more question you complete in the least amount of time, the higher will be your chances of topping the quiz leaderboard. So, apart from giving the correct answers, you have to keep and watch on the time as well. So it will play a crucial role. And after this such informative session, I think this will be a piece of cake for you guys. Okay, I see 10 participants.
They just refresh. I think I can see 19 registrations we
Okay,
have. So I mean, it's a good. We'll wait for 1 more minute. I can see more people are joining. So we'll wait for 1 more minute and then we'll start.
okay.
And yeah, if anyone is facing any issues in order to register in the quiz, please put it in the chat so we can also I can help you one to solve that issues.
Yeah, and also you don't need to log in via any Google account or any email ID. You can just use the guest login. So that's the best part. Okay, let me refresh it.
Yeah, I think they just let's start.
Okay. Okay, so guys, let's start the first question. Here we go. 3, 2, and 1. Okay. So the first question, App Mesh is dash level communication across AWS. The options are network, application, social, and physical. Okay, so we are getting some responses here. Okay, 10 seconds, 9 seconds. Okay, so what's the answer? Okay, so the answer is application. 7 participants that gave the right answer. Okay, so I see that most of have gone through the network. No worries. Okay, so on the leaderboard we have Ajay on the first place. Second place is Mohit, and the third place is Akshay. Okay, let's go to the next question. Okay, be ready, guys. Microservice should be dash loosely coupled, loosely cohesion, tightly coupled, low cohesion, loosely coupled, high cohesion, tightly coupled, and high cohesion. Okay, we are getting some answers. Okay, think guys, this may be a trick question. 5, 4. Okay, so let's see the answer. So it is loosely coupled and high cohesion. Okay, so we have changed in the leaderboard now. We have Sakti on the first place, Akshay, and then Ananya. Okay, let's move on to the next question. You as an AWS account owner only need to provision and maintain the dash, master node, worker node, Kubernetes API, and control plane. Okay, we are getting responses. People are being very quick. 10 seconds. 5, 4, 3, 2. Okay, let's see the answer. Okay, it's worker node. So there is again change in the leaderboard. We have Ajay again on the top, and then Sakti, and then Bhavesh. Let's move on to the next question. Okay, here you go. When using Amazon EKS, the dash is a tool that allow you to use AWS IAM credentials to authenticate against Kubernetes cluster. We have options here: IAM Authenticator, Kubernetes API, EC2 access key, and key management service. Okay, be quick guys, 8 seconds. 4, 3, 2, 1. Okay, let's see the answer. Okay, it's AWS IAM Authenticator. Okay, we have Ajay on the first place, Akshay on the second, and Aparna on the third. So there is a change in leaderboard now. So in every question, we are getting a new people. Okay, next question. Which proxy is used by App Mesh? Rust, Nginx, HA proxy, Envoy. I think this will be an easy question. Okay, 16 seconds. 9 seconds. 1 and 0. Okay, so let's see the answer. It's Envoy. Okay, 80%, 81% have given the correct answer. Okay, let's see the leaderboard. We have Ajay on the first place, Akshay on the second, and the third place is Aparna. So there is no change in the leaderboard. Let's move on to the next question. App Mesh works across services except AWS Fargate, EC2, Code Deploy, EKS. Okay, 16 seconds. We are getting some answers. Try to think, guys. It's an easy one. 4, 3. Okay, so time's up. Let's see the answer. Okay, it's Code Deploy. And again, 71% have given the correct answer. Okay. So on the leaderboard, we have again Ajay, Akshay, and Aparna. So there is no change. Come on, guys, buckle up. You have to beat them. Okay, next question. After testing an application hosted on Kubernetes cluster using Amazon EKS, you want to delete the cluster entirely from your dev environment to minimize the cost what is the recommended method to complete deleting EKS resource? Okay, so they are asking for deleting the resource, what is a proper way? 6 seconds, 5 seconds, 3, 2, 1. Okay, time's up. Let's see if we have some changes here or not in the leaderboard. Okay, so the correct answer is delete pod deployment first, then active services, and last delete your EKS cluster. Only 4 participants have given the correct answer. Okay, we have changed in the leaderboard. Ajay is still on the first place, Akshay, and then Sakti. Okay, guys, now the last question, that is the 8th question. Okay, here we go. The control plane does all the following tasks within Amazon EKS except for which one? Okay, guys, it's the last question. Think and then answer. Okay, we are getting some responses. Last 7 seconds, 5 seconds, 2, 1, and 0. Okay, so now let's see the answer. So it's the option 1, provision and maintain worker nodes. Okay, now let us see the leaderboard. Okay, so on the first position we have Sakti. Okay, so there was a change. On the second position we have Ajay, and the third position is placed by Akshay. So congratulations everyone. Okay, better luck next time for the those who participated and could not make it to the top 3. I'm sure you will definitely make it to the in the next quiz. Okay. Yeah, Sanchit, over to you.
Thanks, Tejas. So that's all what we have from today's session. Thank you so much for everyone joining. We'll ensure that all the questions what we have, like the Slack channel link you talk about, the meetup group link or everything, will post the links as well as a presentation. I'll upload on the Slack as well as on the YouTube channel. So please do go through the presentation and let us know if you have any questions. So that's all from AWS UserGroup Mumbai for our first session. There are many more sessions which are lined up in upcoming weeks. So please do follow AWS UserGroup Mumbai, and I'll see you in the next session. Thank you so much. Have a wonderful day ahead.
Thanks so much,